Hey guys, Mrs. Dorsey here. I've missed all of you guys since we've been out with this crazy world pandemic that's been going on. Just a few things that my family and I have been doing. We live on about 36 acres, and so we've been able to go to our pond and fish or just go for a nice walk. So that's been really cool. I just want to give a shout out to my second hour. And I also want to give a shout out to my mom in Michigan who's watching. So, hi, Mom. Okay, I really thought about what lesson did I want to start out with. So I decided to do something that was a foundational part of algebra. So it gives you guys a good starting point to really prepare yourselves for 8th grade. And even those out there that are in the 5th grade, 6th grade, 7th and 8th grade that are watching, this is a great thing for you to do at home. So while I start to go over the first 2 slides, go ahead and get a piece of notebook paper and any kind of writing utensil. Does not have to be a pencil, so that you can work the problems out with me. Okay, here we go. So the essential question I want you to keep in the back of your mind as we go through this lesson is, how can you use numbers and symbols to represent mathematical ideas? And that means, how can we use letters, so variables. Symbols could also be shapes or pictures of things that we might use every day, like apples or bananas. So keep that in mind. Okay, what we're going to learn about today is we're going to learn to identify parts of an algebraic expression. And if you guys remember, an algebraic expression does not have an equal sign. If it has an equal sign, then that is what? An equation. Write an algebraic expression in simplest form by combining like terms. And these are some vocabulary words that we're going to go over here. So, these are probably too small for you to see, but I will go ahead and read them with you. The first word is term. A term describes the parts of an algebraic expression. So I want you to imagine like a chocolate chip cookie, which are actually my favorite cookies. And think about all the different parts that go into that cookie. You've got flour, butter, salt, sugar, I think probably baking soda or baking powder. I don't cook, so I don't really know. I'm just guessing. And of course, the chocolate chips. So all of those ingredients are terms. So the different parts, the numbers, the variables, the constants, the coefficients, those are all the ingredients or the terms of an algebraic expression. The next vocabulary term is a constant, and that is a number without a variable. And if you guys remember from previous lessons when we were in school, it stands alone. It's really lonely. It doesn't have a date for prom, which is kind of depressing, but, you know, more power to them. Coefficient, a number that's attached to the variable. So if you see a number and a letter stuck together, you know that that has a coefficient. A variable, it's a letter that represents an unknown number, amount, or value. So if I'm talking about, let's say, I want to make t-shirts and sell them for $10 each. I don't know how many t-shirts I'm going to need to make because I don't know how many people might want to buy them. So I could use T to represent the amount of t-shirts I might make. Like terms. Like terms are variables that can be combined or constants be combined. So we've got variables in one category, which are letters from the alphabet, or constants that are in another category. And remember, those are the numbers that stand alone. I can't put together A and T because they're in 2 different groups. Simplest form. Combining like terms into the smallest form possible. So think of a fraction, like let's say 5/10 or 5/10. If I put that in reduced form or simplest form, then I would get 1/2. Well, that is the same concept when we put algebraic expressions into simplest terms. I want to get it as small as I possibly can. Okay? All right, this is our first problem, so hopefully you guys have a sheet of notebook paper or any kind of paper, and we're going to go ahead and do it together. So this says identify the terms, coefficients, and constants in the expression 6n minus 7n minus 4 plus n. Now remember, earlier in the school year, I told you guys that in the land of algebra, because that's a cool place to be, the plus and minus sign have two jobs. The first job is to act as an operation, so adding or subtracting. The second job, which is the magic part of being in the land of algebra, is it tells me whether my term is positive or negative. So the terms in this algebraic expression are 6n, negative 7n, negative 4, and positive n. So you can see the minus symbol told me that 7n was actually negative. And then the same thing with the minus 4s, negative 4, plus n told me that it was positive n. Now, if you notice, there's nothing in front of 6n. And that's because there's nothing that needs to be connected with the 6n. So if you don't see a symbol in front of it, then you automatically know it's positive. Okay, so let's go to the like terms. The like terms would be anything that are the same. So anything that has an n or a constant that stands by itself that can be put together with something else. So our like terms are 6n, negative 7n, and n. I can't put anything with the negative 4 because there aren't any other numbers that stand alone that can be put together with it. Coefficients. Remember, coefficients are any numbers that are attached to a variable or letter. So my coefficients are 6, negative 7. Oh, I was about to write n. Do not write, I'm kind of glad I made that mistake. Do not write the variable when you are writing the coefficients because that is not a part of the coefficient. Now, if we look at n here, there's no visible number in front of it, and that's because we automatically know it's 1n. Now, if you need to write that 1 in front of the letter, that's not wrong. I know that some of you guys are visual learners, and you need to be able to see that 1, and that's totally fine. So the constant, remember that is the number or numbers that stand alone. They are not attached to a variable. So in this example, negative 4 would be our constant. Now, if you guys have any questions about the lesson I'm teaching today, feel free to log into your Google Classroom in the hour that you have me and just sort of ask a question. Or if you are not in my class and you want to contact me about a question, you can email me nicole.dorsey@sequoiaeagles.net. Okay, the next example we have is negative, or not negative, 3x minus 5 plus 2x minus x. So we're just going to identify the terms, like terms, coefficients, and constants. So the terms in this example are 3x, negative 5, 2x, and negative x. The like terms in this example are 3x, 2x, and negative x. And for those that are visual learners, I'm going to put negative 1x so that you know what I'm talking about. And the coefficients in this example are 3, 2, and negative 1. Remember that negative 1 is just understood when you have a variable that stands by itself. The constants in this example are just -5. Okay? Now, if we go to the next problem, it says, write 4y plus y in simplest form. Remember, simplest form is when we're putting together an algebraic expression until we can't make it any smaller. And I've got some steps over here for you to follow. Step 1 is to group like terms. Step 2, combine like terms. And step 3, make sure the variables come first. I always add that in because when you get into higher mathematics like Algebra 1, Algebra 2, geometry, you are going to have to put those variables in alphabetical order. So it's just a good habit to get into that form now. So I've got 4y plus y. I like to make the variables represent something. So when I think of y, I think of yo-yos. So I've got 4 yo-yos plus 1 yo-yo, and I get 5 yo-yos. So 5y is your final answer. In this example, it says write 6n minus n in simplest form. And once again, I've got my steps over here. So I'm going to give n noodles. I'm Italian, and I love spaghetti. So 6 noodles minus 1 noodle means I probably ate 1, and I have 5 noodles left. Okay, don't forget the variable that stands by itself means 1. Okay, this one says write -5g minus 5g in simplest form. Now, some of you are probably saying, oh, that's easy. It's 0. But if you remember your integer rules, it is not 0. A negative and a negative. Imagine I have parentheses around this -5 right here, and there's a plus sign in the middle. So our rules of adding integers are same sign, and we just add. So your answer is -10g. Also imagine on a number line, and we're on -5 right here, and we're subtracting 5 more. We're not going to go towards 0. We're going to go 5 more away from 0, and that's also how we land on -10g. Okay, so in this example, it's a little bit more complicated. We have some groups of like terms. We've got 7x minus 2 minus 7x plus 6. So I'm going to group my like terms together, and I've got 7x and -7x. If I smush them together, it becomes their own algebraic expression. So the negative sign no longer acts as solely as a negative. It now acts as a subtraction symbol. I also have -2 plus 6. So 7x minus 7x is 0. -2 plus 6, remember your integer rules, opposite signs, keep the sign of the bigger number and subtract. So that would be a +4. Now 0 plus 4 is 4, and that's my answer. It's okay when you're putting like terms together if you end up with an answer that doesn't have a variable. Just because you're dealing with algebraic expressions doesn't mean that your answer has to have a variable with it. Okay, next example. We've got x plus 11 minus x minus 11. So I'm just going to group my like terms together again. I've got x minus x over here, and I've got 11 minus 11 over here. And now I'm just going to do the math. X minus x is 0. 11 minus 11 is 0. Hopefully there were no hesitations there. And 0 plus 0 is 0. Look at that, I made like a face. You can get 0 as an answer in algebra. And I snuck this one in there because a lot of the times when we do math problems and we get an answer of 0, we think it's wrong. But remember, 0 is a number just like 1, 2, 3, 4, and so on. So let's go to the next problem. Ooh, this is a word problem. These are fun. Don't let word problems intimidate you, okay? Go down. Oh, there we go. Okay, sorry about that, guys. Don't let word problems intimidate you. They're just math problems with words mixed in, okay? So at a concert, you buy some t-shirts for $12 each and the same number of CDs for $7.50 each. Write an expression in simplest form that represents the total amount spent. So we've got two things going on here. We've got multiplication and addition. The word each means multiplication, $12 each. So I know that that is going to be represented by 12x. And represents addition. So I'm going to go ahead and write my addition sign. And then if I go down back here, I've got $7.50 each. So that's that multiplication again. So I'm going to write $7.50 each. Now, how did I know that X represented the same thing, even though they're two different items? One's a t-shirt, one's a CD. And it says because the same number. So I bought the same number of t-shirts as I did the same number of CDs. So if we just add those together, we get $19.50 times X. You don't necessarily have to have the dollar sign, but if you want it, you can go ahead and write it. Okay, I believe this is our last problem together. Well, let me pull that down. Manfred buys some boxes of cereal for $4.85 each and the same number of bags of pretzels for $2.90 each. Write an expression in simplest form that represents the total amount spent. So this is just like the problem we did before, okay? So what I'm going to do is I'm going to go ahead and circle some things that are important to me. So let's go ahead and break down the word problem. I know I'm going to be dealing with $4.85. I also know I'm going to be dealing with $2.90. So I'm going to go ahead and write those dollar amounts down. $4.85. And then I'm going to come over here and go $2.90. Now I'm going to try to figure out where does my variable go and what operation am I going to be using. So if you remember from the previous problem, each represents what mathematical operation? You guys are right. It means multiplication. So I'm going to go ahead and represent with X. Now remember, in algebra, X does not mean times. It now represents a variable, an unknown number. So you can use X only if it means variable. So now we're also going to look at $2.90. That has each, which also means multiplication. And I'm going to choose X again to represent my variable. Now, how do I know what operation to connect these two values with? And if I go back up into the word problem, it says boxes of cereal for $4.85 each, and. So the word and means what? Addition. Very good. So I now have written an algebraic expression. Now, guys, the reason why I broke this one down is because I don't want you to be intimidated by word problems. You guys have all the tools you need to be successful to work through the word problems. There's only 4 possible choices: addition, subtraction, multiplication, or division. So you've got a 25% chance at the start to get it right. And it's okay if you get things wrong. When you guys make mistakes, that gives you an opportunity to learn and your teacher an opportunity to see where your shortfall is. Where do they need to give you some extra help in order to help bridge that gap? So now that we have our algebraic expression, we're just going to add them together. And I'm a visual learner. I don't like to add just straight across, I've got to set it up as what I call the stacking method, which is what most of you are familiar with. And of course, I don't have a calculator with me, and I'm not a human calculator, although I'm sure some of you probably think I am. So we're just going to start at the right and add going left. 5, 8 plus 9 is 17, carry the 1. So $9, and no, I'm now multiplying. And I'm sure some of you guys are laughing at me right now at home because I'm a math teacher and I just made a mathematical error. Maybe I did that on purpose just to see if you guys were on top of things. I've been known to do that, okay? So 4 plus 2 is 6, not 8, and plus 1 is 7. So $7.75 X. Now, I've got 3 kids at home watching me right now at my house, and I know as soon as I get home, they're going to give me all sorts of heck for the mistakes I've made on today's lesson. But that's okay. Mistakes are great. It's an opportunity to learn and grow. Okay, so let's go to this slide. Now, these are some things, remember at the beginning of the lesson, I wanted you to hold on to this essential question. And how did what you learned today help you answer the essential question? How can you use numbers and symbols to represent mathematical ideas? And this is a really important question because math is all around you. I've had so many kids ask me the question, when am I ever going to use this in the real world? And the answer is you use it all the time, every day. When you buy something with your own money and you're having to figure out, do I have enough money to purchase all these things that I want? That's math. At some point, somebody taught you how to calculate those things. If you grow up and you own your own business, you're going to use algebra all the time. And you're especially going to use algebraic expressions because let's say you end up owning a bike company. And at first, you just start producing bikes. That's simple algebra. But let's say you expand your business and you start making scooters and skateboards. Well, that's more than one variable. You've got the bikes, which is represented by the variable B. You've got S for skateboards. And of course, we can't use S because that represents skateboards. So we could come up with like maybe R for the scooters. That is some complicated math, but you've already learned it. And so because of that math, you're going to learn how many bikes you've got to produce, how many scooters you have to produce, and how many skateboards you have to produce just to break even. Breaking even means when you're not in the red, you're not losing money on your company. So those are different things that we do every day that affects us that's related to math. So these are some examples of answers that you may have thought of as you were doing the lesson with me. So let's go over the question again. How can you use numbers and symbols to represent mathematical ideas? And the first thing I came up with is by using like terms to simplify expressions. Remember, I am all about the easiest way. So if there's a shortcut I can come up with in math that I'm going to get the same answer, I'm going to use that, and I'm going to teach that to you guys. The second one is by writing expressions in simplest form that represent real-world situations. And that is what math class is all about. It's about teaching you ideas that when you in high school or you go on to a technical school or you go on to college and you graduate, you can take that knowledge that's in your brain, okay, and you can go apply it to the real world. So that's obviously the end of my lesson, but I want to go over some things with you that you guys can do at home in these next 4 to 5 weeks while you're on distance learning. So I love YouTube. As long as you have your parents' permission, YouTube is a wonderful resource that you can use to refresh your brain. Math Antics is a great YouTube channel. Yay Math. Those of you that had me for Algebra 2 several years ago, you hated those videos because the guy that taught it is a real dork like me. But he's funny. And when you're taught something in a fun or funny way, you're going to remember it. You know, with my students out there, when we go around town, now if you haven't had me in class, you're not going to know what that is. But if you have, you remember what we studied. Another great app that you can use on an iPad or a phone, or I think even a Chromebook, is Cuda Software. They have all sorts of worksheets that you can print off, or even if you don't have a printer at home, you can copy them off of your phone or tablet onto a sheet of notebook paper, and that's great practice. And it also gives you the answer key. Don't use the answer key to cheat, but the answer key, if you use it properly, is a great way for you to check your work. Okay? Another app that I really love is Khan Academy. Right now, you're able to download it for free, and it's kindergarten all the way through 12th grade. You get to choose what classes you want to learn for high schoolers and even our middle school kiddos. You can start doing that ACT prep, okay? So use those resources that I've given you. You don't have to do just what your teachers assign you, because that's not going to take you a whole lot of time because we're not in a regular school setting. So keep your minds fresh. Ask me questions in Google Classroom. Don't forget to email me. And I love you guys. You're important to me. And I will see you guys next week.